the earliest starting and finishing times. So the earliest starting time is the minimum amount of time it takes to complete all prerequisite activities. And the earliest finishing time is the quickest time it can be finished. Hopefully this makes more sense in a second. So let's have a look at an activity chart. So we've got our start. And our finish. We've got activity A taking 4 minutes, activity B taking 5 minutes, activity C taking 6 minutes, D taking 7, E taking 8, and F taking 9. Now, wherever there's a vertex, we want to draw a little box with 2 spaces. And the space on the left is where we're going to put our earliest start time. Okay, so EST stands for earliest start time. Now, the earliest start time at the beginning is always 0, because can't start before we start. And let's have a think about it. To go from here to here, we have to go along each one of these paths, because each one is a prerequisite for this to get to here. So when is the earliest time I can start doing all of these activities? Well, if it's going to take me 4 minutes to get here, if I finish this one in 4 minutes, I'll still have 1 minute left to do activity B, and I'll still have 2 minutes left to do activity C. This can only be done once all prerequisite activities are completed, and it has to be the longest one to give the next earliest start time. So the longest one is going to take us 6 minutes, so that has to be the earliest start time for that location there, because if we finish this one in 6 minutes, this one potentially could have been finished 1 minute ago, and this one potentially could have been finished 2 minutes ago. And using the same principle to get to here, so if I start this one 6 minutes in, doing D is another 7 minutes, which would take me 13 minutes to finish. And that would be the earlier, but then looking at this one, another 8 minutes, 6 plus 8 gives us 14, and 6 plus 9 is going to give us 15. So again, looking at the longest one is going to give me the earliest start time here. So taking the longest one, it's going to give an earliest start time of 15. So again, very important, you have to use the longest edge to get to your next vertex. Let's look at the earliest finishing time. So the earliest finishing time is going to be the earliest start time of the previous vertex plus the weight of the activity leading up to it. So for A, the earliest start time is 0, because that's the vertex before A, plus its own weight of 4. So the earliest finishing time for A is 4 minutes, because I could start it right from the beginning. The earliest finishing time for B is 0 plus its own weight, which is going to be 5. So the earliest I could finish B is within the first 5 minutes. And for C, it's also 0 plus 6. And we get 6 minutes is the earliest finishing time for that activity. Now for D, it's the earliest start time of the vertex before it, which is 6, plus its own weight of 7, to give us 13 minutes is the earliest finishing time for that activity. For E, it's the vertex before it, which is also 6 plus its own weight, to give us 14. And F, the vertex before it plus its own weight, to give us 15. And they're all the earliest finishing times of all those activities.